Okay, so I'll start sharing my screen, then we can start. And when it's time, we'll move to digitalization. So just let me know when you can see my screen. Okay, 1 minute. Good. Okay, so can you see my screen now? Good. I think it's okay. Fine.
Yes.
Good. So today we'll be discussing measure phase. I would try to be um, slow and fast as possible so that we're able to accommodate those the two sections in this webinar. I'll ask that we all mute. Just check your mics and mute your mics so we have minimal distractions.
Remember, to arrange the medical evacuation, like the Cinema for Peace Foundation, well, they have said that when there's a war plane and when you hand it over into the care of German authorities, you would then take more position. Particularly surprising because you've been possible to an induced coma.
Okay. Let's all mute so that we have minimal distraction. I don't have to always go look for who the noise is coming from. Okay, please. Thank you. Okay, good. I know most of us know me already, so I would not spend so much time on my introduction. So I'm Dominic Wangwaracha. I'm a chemical engineer, ISO certified, Six Sigma with over 9 years experience in manufacturing. Today, what are we learning? We're continuing in Six Sigma. We started last time with the define phase. We did an introduction where we had Chinedu Woke, the continuous improvement manager at Food Tree House in Canada, speak to us. So we understood the pathways for DMAIC. Today, we'll be looking at measure phase to understand how to identify what you want to measure, how you plan to collect data. We'll also look at how you determine the baseline performance. So just to take us back, like a recap, we know there are 5 phases here. We said there are 5 phases and over 15 processes or steps with over 35 toolkits. That's what we agreed the last time. We looked at define. We explained what's inside define, what's inside measure, analyze, improve, and control. So in that last discussion, we looked at define. So understanding what customer and business requirements were. We looked at voice of customer, affinity diagram. We did a case study on Kano analysis, critical to quality. Interestingly, we learned how to develop a project charter. That's what one of the things that Chinedu helped us with. He gave us also a sample of how to develop a project charter. We looked at SciPoc, how to create one. But in this study, we are looking at measure phase, just the measure phase. So in this phase, we are looking at how to identifying what to measure. So we'll be looking at, there's approximately 15 tools here. We won't be able to go through all of them today, but we'll be able to look at some of them. I think important for us is to be able to look at the value stream map in identifying what to measure. We'll look at the 8 waste. We've looked at that before, but it's also very important that you always look at your 8 waste when you're trying to identify what you want to measure. We'll look at the cost of poor quality. Then plan and collect data would look at sampling, look at how how data collection plans should be developed. For the baseline performance, I would refer us back to our process quality control webinar that we did. So it's our advice you go to my YouTube and look at the video for process quality control. That will help us for our step 6. It's basically what we did then using MinTab that we are going to look at in step 6. Okay, so for step 4, it's identify what to measure. So when you decide to do a Six Sigma project, you need to identify what you want to measure. Well, how do you identify that? You need tools. There are some tools you need to use to identify those waste, those challenges that you want to measure. So you need to look at your process or your system. Someone's saying something. So you need to look at your process or your system. Oh yes, you get soft copy after. So you need to look at your process and or your system from the beginning to the end. So those are one of the things that we'll be looking at in the value stream map phase. But let's see what it's about. So what is value stream map? So it's a lean tool. It uses a flow chart approach to identify from the beginning of your process to the end of your process. So you will define what the beginning of your process or your business process is to the point where it ends. When you are able to identify that and draw a process flow map around it, then you're able to pick where your constraint is, where your problem is. So what are the things that we need to consider when drawing a value stream map? You need to understand what your non-value added work are. So the actions that should be eliminated, things that don't add value to your process. So those are the things that we want to eliminate. Those are the things that we call the waste. So what are the essential non-value added work? Those are wasteful actions, but they're essential. You have to, you don't have an option because of the current operating conditions that you have. So they are also waste. They waste time, but you don't have an option. So they are there, but you need to put a system in place to eliminate them. Then you also have the value added work. So these are actions that add value to your customer. This is what your customer wants at the end of the day. So if you look at this closely, you see, so imagine producing motorcycles. What your customer wants at the end of the day is a motorcycle that is fit for you. So every step that it takes to make that, you need to be able to eliminate if it's a waste, or you need to be able to improve if it can improve your efficiency. So there's a calculation where we calculate the process cycle efficiency. So to do this, we sum up our value added time over the total time it takes for production. So value added time divided by the total time it takes for production, and that is that's what gives you your process cycle efficiency. Oh, okay, I think it's charts that I don't need now. Okay, so this is what a value stream map will look like. I just put a small case study here from production and operations to supplier. So the supplier brings in your raw materials, it's transported to your warehouse, then you move it to where it is dispensed, you move it to where it is mixed for each of your process. So when you're drawing this, note that for each of your process, you need to put the value added time. Here I'm saying 10 seconds, which is the total. And you need to put the essential non-value added time. You need to put the non-value added time. So if you look at the process I put here for bottle production as an example, you dispense your raw materials, you mix for your value added time is 30 seconds, and the essential non-value added time here is 30 seconds. So it could be the time the operator or the manufacturer uses to move materials from place to place. He has to, but it's essentially non-value adding when you could automate it. So you look at your filling, the process, your capping process. The value adding could be 5 seconds. And labeling and coding. So if you look at your non-value adding time when at this space, at this point of our process, that's the labeling, it's 160 seconds. So you have, so if you look at this process closely, you see your constraint is more at your labeling and coding. So that's when you have where you have the highest non-value adding time. Also in palletizing, you have 100, and in distribution, you have a non-value adding time of 90 seconds. So when you look at all of this, it tells you where your waste is. So when I look at my process map, after drawing this, it's very easy to identify that my waste, more of my waste happens from when I start labeling to my distribution phase. So it's at this point that you put a process in place. So here we have already identified what we need to measure. So this is what it's about. You identify what you need to measure. For us, our waste here happens at labeling. So it means we might need to measure the number of defects that you have in labeling, or the number of breakdowns that you have from the labeling machine. So that's how you identify it. So for value stream map, there are tools um, that you could use to draw it. So these are most of them. So I will send this to us so that you can always crop and use to draw the value stream map, because you need all of this. Something here to show you that this is production control, something to talk about customers, something to like the truck that shows logistics. So you pick all of these tools, use them to draw the value stream map. So maybe when we get the soft copy also, it will help us understand better what we need to do. So one other tool is cost of poor quality. Cost of poor quality is one very important tool that will help us identify what we need to measure. So the cost of quality is equal to the cost of poor quality and the cost of good quality. I know most times we're always saying cost of poor quality, but we need to look at it holistically to understand what exactly is our cost of quality. So yes, it might include the poor one and the good one. So for cost of poor quality, we are looking at the internal cost. So cost as a result of rework, cost as a result of reinspection, cost of poor quality external could be as a result of maybe regulatory issues, corrections, warranty loss, brand reputation issues. You get a fine from the regulatory authorities that you need to scrap or rework your product. That's an external cost. So those costs are the costs that are of poor quality. So they are internal and external. So we also have our cost of good quality. It could be appraisal cost, that's the cost that you use in inspection and testing. Please note also that you could have an increased cost here if you do not, if you don't have the right system in place. Your cost of good quality could also be high compared to what you have previously. So you have your prevention cost also, so the cost where you use in testing so that you don't have a problem in the future. So we always use this iceberg diagram to explain what cost of quality is. The visible ones are the ones you see at the top, but there's obviously so many things under that are causing those warranty issues, inspection issues, scrap issues, and rework concerns. So the cost of quality is a very, I think I did a slide. I will also share that on how to use cost of quality to design a business case. So I know I did one case study I will share with us also. So if you see this, it's just a simple one. Before you implemented the process or before you started buying a particular type of raw material, you noticed that your scrap was, let's say, three naira. And after you bought this particular material, you noticed that your scrap increased to 12 naira, your inspection increased by 50%, your rework increased by 71%. There was, okay, let's say no adverse event, but your consumer complaints increased by 71%. So you could actually use your cost of poor quality to identify what to measure. If you see here, it's already obvious that the material that we're using is the reason for, is where our challenge is coming from, is where we need to measure. So the cost of poor quality or the cost of quality is a very good tool to help us identify what to measure in this instance. Oh, I thought someone had a question. So we'll also look at the 8 waste. I know we looked at this previously, but it's also very important in identifying what to measure. So is anything other than the minimum amount of information, that's equipment, material, effort, that's required to add value to a process? So one good way of memorizing the 8 waste, which the Chinese will call muda, is downtime. So we look at defects. What are the defects that you've identified in your process that you need to measure? What is overproduction that you have? What are the waiting times that you have in your process? What are the non-utilized talents that you have in your process? What are the inventory issues? What are the transportation issues? What are the motion issues or the extra processing issues? So each of these could be called value adding, business value adding, or non-value adding, like we've discussed in our value stream map. So when you design your value stream map, you use terminologies from here or the understanding from all of this to create your value stream map. So you understand when we say waste as a result of defects, what do we mean? When we say waste as a result of overproduction, what do we mean? When we say waste as a result of waiting, what do we mean? When we say waste as a result of skill issues or waste as a result of inventory, so is it? So I'll give you a very good example when it comes to waste for inventory. You take $2 million worth of goods. Please, we need to mute our mics. Can we mute our mics, please?
Your something is on.
Yes, mute your mics, please. Thank you. Okay, thank you. Please mute your mics. Thank you. So I'm giving you a good example of waste of inventory would be you want to produce, let's say, 10,000 cases of a disinfectant, and you bring in 2 million naira worth of raw materials. So what happens in this case is you're holding high inventory in your production facility. So that's already a waste that's affected because you won't use the inventory to produce the 2,000 cases that you want to produce, and you keep that inventory for close to 6 months. That's already a waste in itself. It's idle time. So you have that idle time, and you imagine you have trucks that will move that material. So you keep the trucks every day because you want to move these materials daily. So you already have waste on inventory, waste on transportation at the same time because you are holding high inventory. So these are the kind of waste that we have in our system. So takt time is just a simple tool that is used most times to calculate to identify what you have to measure. It talks more about, it's a German word though. It talks more about how frequent a part or a component must be produced to meet the customer demand. So if in a shift you have a particular number of time and you have to produce say 200 cases of that product, so your takt time is when you take the time that you have available and divide it by the number of pieces that you need to produce in that period. That's what you call your takt time. So it's just it's a terminology and a tool that is used in Six Sigma. So it's good to know. So our next step is to plan to collect data. So now initially we've identified what we have to measure. Now we need to plan to collect this data. So what are the tools that we need in this place, or what do we need to know? So first of all, you need to decide and understand your process very well. That's why I said we must draw a value stream map or a process map. You just need to draw a process map. You need to know from the beginning of your process to the end, from supplier to customer, understand the whole process so that you are able to identify your baseline challenge. You know the data that you plan to collect. If you look at our previous example, the place where we had the biggest waste was in our labeling area. So we'll collect more data in labeling and coding of our products. So we need to check. So like I said, check the input, check the process, and check the output measures as you plan to collect your data. As we know, there are two types of data. We have the qualitative and the quantitative. So when we say qualitative, we know these are the subjective ones. The interesting to note here is, as much as you have different types of data, you'd understand that your statistical test or analysis for them will be different. So when you have a y variable that is discrete, and x variable, you might do a chi-square test. You have a continuous and a continuous X and Y variable, you use regression analysis. We'll look further into this when we have to understand, okay, what normality is, what our p-value is in our process. But it's important that you understand the type of data that you're trying to collect. What data are you trying to collect? If you're trying to collect how aligned your labels are, then you are looking at an attribute data. So I'm checking, how many aligned labels do I have? If I'm trying to check weight values, then I'm looking at the quantitative data. I'm trying maybe 6 meals. So we lose 6 meals or 6 gram or 10 kg from every product that we produce. That's a waste. That's a place that we need to measure. Okay, so we also need to look at how to sample it. What are the sampling techniques that we have in place? So sampling here is just collecting data. So it's either you're collecting through destructive testing, or you're collecting when there is a constraint or a time and cost, or you're collecting when the population cannot be easily captured. So there are 8 ways in which you can do this. We'll look at 4. The random sampling that we know about, the stratified random sampling, the systematic sampling, and the cluster sampling. So if you look at random sampling, is just pick a whole lot. You have 100 samples and you randomly take each piece. Maybe you take 4 pieces, just randomly take 4 pieces from what you have. If you look at stratified, you say, okay, we produced for 8 hours. I want us to sample randomly, but in stratified. So in the first 2 hours, pick 2 samples. In the next 2 hours, pick 2 samples. Or we produced for a whole year. In the first quarter, pick 2 samples. In the second quarter, pick 2 samples. In the third and fourth quarters, 2 samples also. Or you might do a systematic sampling. So you say, okay, out of everything that comes out of the line, when the okay, so we need to mute baby. Okay, so when the ninth bottle comes out, we need to pick that as a sample. You can also digitalize it. So those are one of the things that Pratik will be talking to us about today. How you could as well digitalize most of these systems that we are talking about. So cluster sampling also the same thing. At every end time, we need to pick a particular number of samples. So, okay, I have a very quick quiz for us here. So you please just put your answers in the chat box, or you can raise your hand to answer it. So we have VIT is a well-known fast-moving consumer goods, and every 20th tube of VIT goes through quality check. What method or what sampling method do you advise that we use for this? I need to mute that person. So the second question is, okay, good. Please just mute your mic so I don't have to mute you. Okay, so the second question is, you have a bakery and you need to randomly select 30 breads per day. So in these 2 examples, what do you think, what type of sampling do you think, from our explanation previously, what type of sampling do you think we should use? Are we going to use the, oh, I hope the answer doesn't come when I click this. Are we going to use the random sampling? You can put your answer in the chat box, or you just raise your hand to speak. Are we going to use the random sampling, systematic, cluster, or stratified? So every 20th sample of it, you need to pick and go test. You need to randomly select 30 bread in 1 day in a bakery. So what I'll give us the answer. I don't know if anyone has put anything in the chat box. Okay, so for the first one, use a systematic sampling, because you are told that every 20th tube that comes out of your filling machine, you need to sample. The second one says just randomly pick 30 bread in 1 day. So you just use your simple random sampling. So the first one is systematic, and the second one the second one you need to randomly sample. Okay, so for baseline performance, I'm at the end. So Pratik, I want you to, I'll make you host. Can you hear me, Pratik? I'll make you host after this so you can share your screen and take us through digitalization. Yes, okay.
Sure, Dominic, sure. Yeah.
Okay, great. So for setting up a baseline performance, so now we've identified what to measure. We have we have also looked at how we are going to pick our samples. When you get that data, you need to check if it is, you need to do like a normality test on that data. Is it a stable data? Is it not a stable data? Is it non-normal data? Is it, so you pick that data, you plot it on Minitab, and you see it helps you check its normality. So it's just to know how likely is it for this random variable underlying data to be normally distributed. So I did one, but the Excel sheet is not here. I can also share for you. We've done a training on Minitab, so you can also look that up on YouTube, where I'll share the link to us while Pratik is taking us through digitalization. Okay, so this is what you see. If you look at my graph here, my p-value is 0.243. So that's, for me, that's what's important. Okay, if you also look at the graph, you see that most of the values here are close to the straight line. So yes, the data looks normal. Yeah, it's not, we don't have so many data off, most of them. So this is the first thing you do, check that your data is normal, so that you know the kind of test, the kind of analysis to do for it, because you move into the analysis phase. Before you move into analysis phase, understand what your data is before you start analyzing. So for p-value, it's an output of a statistical value which is plotted on Minitab. So if you have, it ranges from 0 to 1. So if your value is greater than 0.05, it means your data is stable. If it is less than 0.05, it means your data is unstable. So it means it's normal when it is greater than 0. So if you look at what I plotted here, you will see that I have a normal data. So it now tells you the kind of analysis that you can do on this. Okay, so I think yield is what we all know. There are 3 types of yield. We all calculate yield in our systems. It could be classic yield, where you just take the units that you make and divide it by the total that you have produced. It could be your first pass yield, the first units that pass through your system process, and you divide it by the total that you produce, or the row throughput yield. So you take the yield from each of the processes and you divide it by the total at each process. So those are the 3 types of yield that you have. So this is one way. These are ways in which you define your baseline. So when they say define your baseline, what are they talking about? Before I started my improvements, my waste was 29 point. If you look at value stream, we had 29.3. Okay, we had 29.3, 29.99, I think, percent. Okay, and over 70% waste. So you defined your baseline that your waste is 70%. You're able to define also what your yield is here, 93%. So it means we need to put a project around the 7% waste that we have here, or the 70% waste that we had when we did our value stream map. So this is all the measure phase is about. Measure your first baseline, that you create a baseline. This is where I'm starting from. This is the data that I want to collect. This is the data that I want to identify before you move on. Okay, so thank you very much. We'll move to digitalization, where Pratik will take us now. But I will share the link for all of this. So on YouTube, you will see how to undergo baseline performance. I did some videos. I've done some videos already. They are there. You just go through those videos. I'll share the slides with you also on how to use a run chart, how to carry out process capability studies, and for both discrete and continuous. Okay, so we'll go into digitalization now. Thank you very much. If there are any questions, please put them in the chat box. I would answer after, maybe when Pratik is answering his questions, I will also answer those questions, and we can look at it. So Pratik, I will make you host now so you can share.
Sure. Thank you, Dominic. I guess the time remaining is 8 minutes. So should we join back again? If that's good.
Yeah, so you can start. Yeah, you start, and we'll all join back when We'll all join back once it goes off, we'll join back immediately after. So
Sure, no problem.
Okay.
So I hope my screen is visible to all.
Yes, I can see your screen. Great.
Yeah. So thank you, Dominic, for providing this platform. Good evening, all. So we at OpexWorks are committed to drive small, medium enterprise manufacturing enterprises towards digitization and Industry 4.0. So when we use these terms, Industry 4.0 or digitization, a thing comes to in that it is more of automation of traditional manufacturing practices. Yes, we are right, but it also comprises of improved communication in between stakeholders, improved self-monitoring, and getting more and more data automatically from machine. It encompasses robotics. It also encompasses AI. It encompasses 3D printing, these kind of advanced technologies. It is related to the handheld mobile phones, which are there in everybody's pocket. It is related to IoT. It is related to that is Internet of Things. It is related to HMI, smart HMIs, smart sensors, integrated softwares, and data visualization at different levels for informed decision making. So the basic design principles when we consider all this is to create an interconnection between different kind of machines and different levels. Hello.
Yes, go on. We can hear you.
Hello.
We can hear you.
Yeah. Okay. So the basic, the design principles behind these are the interconnection between machines, interconnection between man-machine, and different stakeholders within the organization or outside the organizations who are part of the value chain in the manufacturing system. So it is about information transparency and passage of safe passage of information. It is about providing technical assistance to the concerned stakeholder to take decentralized and to take decentralized way for decision making and problem solving. We should understand it is all about data. So Industry 4 is all about data. It is about digitization and integration of vertical and horizontal manufacturing value chains and the data which is flowing through all these manufacturing value chains. It is about digitization of product services, and it is about digitization of our business models, which will contribute towards having increased customer value or enhanced customer value. So with this preamble, we will now go to our platforms which help or which have helped our customer for in increased digitization towards quality, cost, and delivery to enhance their customer value. So OpexWorks established itself in 2013. We are having our office headquartered in Pune. So Pune is a city wherein you will, Pune is a city in India, Maharashtra, wherein you will find a unique culmination of IT and manufacturing. So we are operating out of the city wherein we have already taken baby steps towards most of the industry, whether it is they are related to large companies or small and medium scale companies. They have taken small steps towards Industry 4.0 or digitization. So we are having 25 years of experience in system implementation for manufacturing industry. We are a product-based software solution company. We have hosted our products in cloud. So there is no installation procedure for our products. You can use it anytime, anywhere as you're using any Google system or Facebook or LinkedIn probably. So we have systems which help our manufacturing industry clients to improve their plant efficiency, performance, efficiency and performance improvement. which help them communicate better in between different levels of stakeholders, internal and external stakeholders. Are all solutions are adhering to lean, TPM, TQM, and are in compliant with ITF. So we are a startup based in Pune who have been who had selected by NASCOM, uh, IT body in India, for their NASCOM InnoTrek 2018 as a startup which is having potential for global expansion. So we are having solutions related to quality management, productivity management, maintenance management. We call it as a RIO, specifically useful for plant efficiency management. Then from the customer supplier relationship perspective, we are having products related to child parts concern management, vendor management system, internal organization communication, audit and compliance management, and daily work management. So who are our customers? So we are catering to 450 plus customers in India. We are catering to world's third largest motorcycle manufacturer, largest manufacturer, Bajaj. Uh, as Bajaj is there in Nigeria as well, with rickshaw and boxer. So we software system which is used by Bajaj is provided by us. So we are providing them softwares related to concern resolution in between Bajaj as a OEM, then their large suppliers, we call them as a tier one, and their supplier and their suppliers as tier two. So we provide them with concern resolution management, child bird inspection system with online PDI submission, PPM tracking for supplier audit and compliance management process, and new product development. We have deployed our system across 250 plus tier 2 SME component manufacturers for Bajaj. That system, they are able to manage and improve the quality, productivity, and maintenance within the plant. We have also deployed our system in NORBREMSE for their advanced shipment notification mechanism. So as we know, the shipment schedule is getting published on the monthly basis for day-to-day requirement, and schedules do get modified as per the customer ask. So we have created a robust system for advanced shipment notification, wherein right from the OEM manufacturer demands to receiving ASN and integration